So first we begin with a little of housekeeping. What this makes is clears all the variables, close all possible open windows, and then it also clears the console, which is this part of MATLAB. And then we begin by defining the material properties. This is the F prime C, the Fy, and the modulus of elasticity with their respective um, unit. And then we also define the geometry. We have the height of the head of the web, the width of the head, and also of the web, each of them on inches. Now this is an interesting part because we can add as many layers of steel as we want, but each one of these variables, they need to be coherent one with each other. Each one of these columns, let's say, each is a different layer. So for example, my first layer is located 0.5 inches from the top, and this value is the centroid of the rebar. This is the number of rebars on each layer, and this is the area of the nominal area of just one of the rebars on each layer. Then we also can define the number of slices, and we can calculate some important properties of the concrete, such as the modulus of rupture and the elastic modulus. And then we can also define this concrete strain. By the moment we can define this value as the ACI, which is 0.003, but later we can use other material constitutive laws, and well, we can use another value different than this one. So let's begin. To solve this problem, what I will do is to define the functions, all of them in this part. So all the code, the main code, will go in this section, and then the functions that I will be using will go below these functions used. So let's begin with the first function. Since we have defined a number of slices here, in this case 100, it might be possible that this number of slices is not compatible with our beam, because in the transition between the head and the web, we need one slice exactly in that coordinate of the transition. So we define the function as follows. The output of the function will be the y coordinate of each one of the slices, and then a new number of slices. The inputs will be the height of the head of the web and the previously given number of slices. We begin by defining the original number of slices as the original input, and then we make a first attempt to generate the y coordinate of each one of the slices. So first of all, we calculate dy, which is going to be the total height of the beam divided by the number of slices. Then we initialize a vector y0, which will contain the same number as the number of slices plus 1. This is because each one of our slices actually will be between two lines. So that is the reason why we will have one more coordinate than the actual number of slices. Then with this loop, we loop over all the elements defined in y0, and then we assign the actual value of the y coordinate by doing this operation. Once we have defined this first attempt, we have to check if there is some element inside y0 that has the same value as the head height. If that is the case, I will say that my new number of slices is exactly the same as the number of slices that the user use it as input, and then I will print a message saying that that will be actually the same number of slices. However, if that's not true, I will create a new vector y0, but I will keep adding 1 to the number of slices. So I do that by using this loop. This is a conditional loop, and all these instructions will be followed if and only if there is not a member, there is not an element inside y0 that has the same value of h head. So if we get into this loop, what we want is to update the number of slices, increasing 1. Then we calculate the new dy, then we calculate a new vector y0, and then this loop continues until we have one y coordinate inside y0 that is exactly the same as h head. So after we finish this loop, we update the value of y slices to my vector y0 after the loop, and then we set the new number of slices as the number of slices that was updated inside this loop. Then we print a message saying that the number of slices has changed. Okay, so now the next step is that once we have the adequate number of slices, we want to calculate the left coordinate of each one of those slices, the right coordinate, and also the length of each one of those slices. So to do that, we will use this function, and the inputs will be the height of the head and the width of both the head and the web, and also a coordinate y. So depending on this coordinate y, we will have to decide if we will assign the coordinates corresponding to the width of the head or the coordinates corresponding to the width of the web. So to do it, we just use a conditional if, and in case that our given coordinate is less or equal than the height of the head, we will give x left and x right the values of b of the head divided by 2. And if that's not the case, the values assigned to x left and x right will be the b of the web over 2. And then the horizontal length of this slice is going to be just the x in the right minus the x in the left. Okay, so now we have created these two functions, one of them to update the number of slices and the other one to calculate the x coordinates and the length of each element. But notice that this function works only for one given value of y. So to calculate this for all the possible slices that exist in my beam, what I will do is to create a new function. I don't remember why I called this plot beam and slices. At the beginning I was creating a plot, but it was too complicated, so let's analyze just this function. So the outputs of this function will be capital X left, capital X right, which contain the left and the right X value for each one of the slices. We also, as an output, we will also have the y coordinate of each one of the slices. We will have a capital L, which is a vector containing the length of each one of the slices. We will have also the new number of slices and the actual dy. And the inputs will be the height of the head, of the web, the width of the head and the web, and the number of slices given by the user. So first we calculate the total height, we calculate the initial dy, and then we call our previous defined function, get y slices, and then we calculate y slices and new n slices. Then we initialize two matrices, well, actually these are going to be vectors where I'm going to save the x coordinates. And then we also initialize an L vector, which will have the length of each one of the slices. So then what we do is to loop over each one of the slices. We loop over the total number of the elements in y slices. And then we call our function get L slice geometry to obtain our x down, or well, this could be actually x left. Let's call this x left. Okay, so then once we have calculated this, and we also calculated the length of each one of the slices, what we do is to add this to the vector capital X left, we add this to the vector capital X right, and we add this to the vector capital L